Hi everyone, welcome to the channel. Today our topic of discussion is going to be the ionic bond. Through this video, I will make sure that all of you all literally understand what is ionic bonding rather than by hearting the definitions and concepts which fall under ionic bonds. Okay, so first of all, in the word itself, when you look at the term ionic bonding, there is one word which will come out as a highlight. This is the word from which actually ionic bonding is derived. Yeah, I'm sure all of you all must have guessed it by now. Ionic bond, the term which is highlighting over here is nothing but ions, isn't it? From the term ions, we actually get ionic bonding. Okay, so as a student having basic knowledge of chemistry, you should be able to tell me what are ions. How do we define ions in chemistry? Ions are nothing but charged species. Okay, so usually the periodic table, which is made up of 118 elements, okay, the periodic table represents atoms, and atoms are neutral in nature. That means they do not carry any charge, okay, but ions are the ones which are charged. Okay, under ions we have two examples. I'm sure you all know that. We have cations, correct, and we have anions. So there are two types of charged species which exist, cations and anions. Cations are the ones which are positively charged. Okay, cations are the ones which are positively charged. Anions are the ones which are opposite. So they will be negatively charged. Okay, so this basic or this background information you all require in order to progress ahead with ionic bonding. Okay, over here we can simply understand that in ionic bonding, ions are going to play a very major role. An important role will be played by cations and anions in knowing what is an ionic bond. I hope so far the introduction is clear. Okay, now I'm going to progress ahead with the definition. Okay, what is an ionic bond? Yeah, so let me put down the definition first. An ionic bond is formed by complete transfer of electrons by one species, or you can say by one atom, and simultaneous acceptance of those electrons by another species or atom. So I have literally given you all the very base definition, like the foundation definition, okay, wherein I haven't skipped any word. Yeah, so this is actually the definition of ionic bond. Let's read through it and then I'm going to explain the same using an example. Okay, an ionic bond is formed by complete transfer of electrons by one species or one atom. So I know that there is an atom who is going to donate electrons. Okay, there is an atom who is going to donate electrons, and simultaneous meaning along the same time. So when the donation of electrons is occurring, simultaneous acceptance of those electrons by another species or atom. So when one atom is donating its electrons, at that very moment another atom is going to accept those electrons. Okay, the bond which is formed in this case will be called as an ionic bond. Yeah, first of all, I hope you all know that whenever I say chemical bond or ionic bond, okay, it's a type of attractive force which is going to hold different atoms together. Okay, so over here what is happening? One of the atom is donating electrons and another atom is accepting electrons. Okay, the force which will exist in such species is going to be called as an ionic bond. Yeah, so it must have clicked to you already how the ions are coming into picture. Whenever an atom is going to donate electrons, it will form a cation, positively charged, and whenever an atom will accept electrons, it will form anion, negatively charged, right? So ionic bond can also be defined as a chemical bond which exists between cations and anions, wherein one species is giving electrons and one species is accepting electrons. Okay, so this is your standard definition of ionic bond. Now, which are the examples, or where do you find ionic bond? Okay, so the second point, so this is going to be your first point that you will have to note. Second point, an ionic bond is formed between a metal and a non-metal. So this is our second point. Okay, whenever you have ionic bond is specifically seen forming between a metal and a non-metal. Okay, so these 2 points are going to give you the basic idea of an ionic bond. Fine. Now there are a few more things that we have to understand. Whenever we talk about metals, okay, whenever we talk about metals are said to be electropositive in nature. Okay, metals are said to be electropositive in nature. What do you understand by the term electropositive? Electropositive are those elements which tend to donate their electrons, because metals are known to be happier when they carry a positive charge. Okay, so metals are usually electropositive. That means they donate electrons. Now if they are donating electrons, what will they form? They donate electrons and form cations. Okay, so metals are the species which tend to donate electrons because they are electropositive in nature, and they are the ones which will form cations. Okay, which is the other participating atom over here? A non-metal. Non-metal are said to be electronegative. Electronegative, that means they are electron loving. They accept electrons. And what will they form? If they are accepting electrons, that means they are increasing the negative charge on themselves. If they are increasing the negative charge on themselves, they will form anions. I hope now each and everything is falling into place for you all. Okay, so what did I say? Ionic bond is usually a bond which is formed by complete transfer of electrons. So there is an atom which is donating electrons, there is an atom which is accepting electrons. Okay, atom which is donating electron is going to be a metal, because metals are electropositive, they form cations, and the atom which is going to accept an electron will be a non-metal, because non-metals are electronegative, they accept electrons. Okay, now what we will do, we will apply all of these points on a simple example in order to strengthen our knowledge on ionic bond. So let us take an example of sodium chloride in order to understand the formation of an ionic bond. 2 points that we have to keep in mind. First is the definition, wherein we need to show complete transfer and acceptance of electrons, and second, ionic bonds are seen between metals and non-metals. Okay, so here we have an example of NaCl, which is your sodium chloride. Okay, sodium is playing the role of a metal, whereas chlorine is playing the role of a non-metal. Yeah, so we have seen that we have a metal and we have a non-metal. Okay, now how do we show the formation? Okay, or how do we show transfer of electrons and acceptance of electrons? Okay, so in order to answer that, we need to focus on the atomic number of the atoms that we are using. Okay, atomic number is basically the electronic configuration. Fine. So sodium has an atomic number of 11. The electronic arrangement is 1s2, 2s2, 2p6, 3s1. Whereas chlorine is 17, right? So electronic arrangement is 1s2, 2s2, 2p6, 3s2, okay, 3p5. Done. This is the electronic arrangement. Yeah. Now we know that for any element to be stable, it needs to have a completely filled valence shell. I will repeat, for any element to be stable, the outermost shell or the valence shell has to be completely filled, right? That's how our noble gases are extremely stable. If you look at the example of sodium, in order to have a completely filled valence orbital, sodium has to get rid of this one electron. This one electron, a single electron which is present in the S shell is going to make sodium highly unstable. So sodium as a metal have the tendency to lose electrons. I have already mentioned metals are electropositive in nature. They lose electrons in order to become stable. So sodium over here is going to lose this one electron. Okay, it's going to lose this one electron in order to form a sodium cation. Okay, if any element loses one electron, it will acquire a +1 charge. Okay, we call this type of cation a monovalent cation. Mono means +1. Okay, if the charge is +1, we call it a monovalent cation. +2 then divalent cation, +3 then trivalent cation. Okay, so we have a species over here which has given one electron. Okay, what did the definition say? If one species is donating an electron, the other species has to accept that electron. So where will this electron go? Where will this electron go, right? Come and have a look at chlorine. Okay, in the case of chlorine, what is happening? I have 3s2, 3p5. This is the outermost shell, right? 3s2, 3p5. Okay, so chlorine has an option. In order to become stable, the option that chlorine is basically having is with respect to 3p5, right? It is very difficult for chlorine to lose 5 electrons and become 3p0. That means 3s2 will be the last shell, right? But losing 5 electrons is going to be extremely difficult, correct? So halogens have a tendency of accepting 1 electron in order to become stable. So from 3p5, chlorine can go to 3p6. p6 is a completely filled orbital. Yes, it can accept 1 electron in order to become stable, and the charge that will be developed on chlorine is going to be a -1. Okay, when it is -1, we will call it as chloride. From chlorine, when your atom is gaining 1 electron, we will call it as chloride. Okay, so sodium you can see is losing 1 electron. Chlorine on the other hand is accepting 1 electron, correct? Now we have our species Na plus and Cl minus. The two of these are going to form an ionic bond, giving us our compound NaCl. So ionic bond is nothing but an electrostatic force of attraction. Electrostatic force of attraction between the positively charged cation and the negatively charged anion. Okay, so in another way, if I want to show the formation of sodium chloride, I can show it over here. This is an atom of sodium. I'm just going to show the valence shell. In the valence shell, I have 1 electron. Okay, and on the other side, I have chlorine. Again, I'm only going to show the valence shell. Yeah, in the valence shell, how many electrons do I have? 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Right? So this is Na and this is Cl. We have transfer of 1 electron from sodium to chlorine. Correct? We have transfer of 1 electron from sodium to chlorine. So what will happen? Sodium over here will acquire a positive charge because it is losing 1 electron, whereas chlorine on the other hand will become chloride. So it has its own 7 electrons plus 1 electron which is coming from sodium. Overall charge will be -1. This is the formation of an ionic bond in sodium chloride.